Hi students, today we are going to discuss one of the most fundamental and scoring topics in physics, laws of motion. And in today's session, we will discuss Newton's first law and Newton's second law. See, these laws are not just theoretical concepts, they form the base for solving a large number of problems in mechanics. So, if your understanding here is strong, many chapters ahead will automatically become easier. And in today's session, we will clearly understand the concepts behind Newton's first law and second laws and learn how to apply them in problem solving. And most importantly, we will solve NEET previous year questions from the last 15 years. So, this will help you understand the exam pattern, important concepts, and how questions are actually asked in your NEET. So, stay focused, think along with me, and try to solve each question before I explain it. So, shall we start our session? Yes. So I have divided this laws of motion into two parts. Part In part 1 we'll cover the three laws of motion, and in part 2 we will discuss friction and vertical circular motion, like block over block problems, all those funda and angle of banking of roads. So all such concepts will be discussed in part 2. So without wasting the time, let's jump into today's topic. And today's first topic is Newton's first law of motion. So, what is this Newton's first law of motion? Every body continues in its state of rest or state of motion unless and until an external force is applied. What does it mean? For suppose you take an object which is in rest position. So, it will be in rest only unless and until you apply a force. For suppose you take an object which is in motion. It will continue its motion unless and until you apply some force to stop it. That means whenever we apply force, then only there will be a change in state of the body. If force is not applied, then there is no change in the state. The body which is at rest will be at rest only. The body which is in motion will be in motion only. Simple example, you take driving of a vehicle. Imagine you are the driver, you are driving the vehicle, okay? Now, for suppose if you want to start the vehicle, you have to apply the force. And suppose you are moving on the road and you have to stop the vehicle. So then also you have to apply the force, you have to apply the brakes. For suppose you want to take a U-turn, that means you have to change the direction of the vehicle. Then also you have to apply force. So in all these cases, we can consider this Newton's first law of motion. In all these cases, force is required. Clear with this statement? So every body continues its state of rest or of motion or direction unless and until an external force is applied. So very simple thing. If you want a change in state of the body, then some force must be applied. This is called Newton's first law. This is a theory statement, but if you take your NEET exam, what is required from Newton's first law is mathematical considerations. What do we consider? We consider equilibrium state of the body to apply the Newton's first law for NEET problems. What is this equilibrium? Suppose consider a body of mass m kgs and imagine there are multiple forces acting on it. So there is F1, there is F2 and another force F3 like this. So if I take the sum of all these forces, force is a vector, right? So we have to consider vector sum. So if the vector sum of all these forces is 0, it means F net is 0. Then acceleration A net is also 0 and velocity of the body will remain constant. These are important. If F net is 0, what will be A net? A net will also be 0. In a bit, you will study Newton's second law, and there you will study about this formula F is equals to ma. So what is A from this? A is nothing but F over m, right? If F is 0, A is also 0. So if F net is 0, A net is 0. What is acceleration? It is change in velocity by change in time. This is 0 since acceleration is 0. So if change in velocity is 0, what does it mean? Initial velocity is equals to final velocity. So velocity of the body remains constant. So you have to remember these 2 points. If F net is 0, then the body is said to be in equilibrium, and under equilibrium A net also will be 0 and velocity of the body remains constant. And there are two categories of equilibrium conditions. Number 1, static equilibrium, and number 2, dynamic equilibrium. See, equilibrium means immediately you must consider F net is 0. Static in the sense what? The body is not moving. If the body is not moving, then we call it a static equilibrium. F net is 0 and body not moving. Whereas if you take dynamic equilibrium, first of all equilibrium, so F net 0. Dynamic in the sense the body is moving this time. So it is moving, but still F net is 0. So when is this possible? If the body is moving with constant velocity. So if body is moving with constant velocity, F net is 0 and it's called dynamic equilibrium. And body is not moving but F net is 0, then it's static equilibrium. Body is not moving, how come F net is 0? That means maybe the forces are acting in opposite direction. If you take vector sum, it is coming out to be 0 and this is not sufficient for the body to move. In that case, what happens? Though forces are applied, if they are not sufficient enough, the body will be in rest only. Don't confuse here. Ma'am, just now you said in Newton's first law, if you apply a force, the body must move, right? But what if the force is not sufficient to move? Imagine you are pushing a wall. Is your push sufficient to move the wall? Not sufficient, right? So force is applied, fine, but that force must be enough to displace a body. If it is not enough, then the body will be at rest only, and there we can consider static equilibrium. Clear? Now we'll see some problems related to Newton's first law. Physical independence of force is a consequence of. What is this physical independence first of all? Let us understand with an example. This is a mass of m1 k of m kg, fine. Let us imagine some force F1 is acting on it. Now same mass m kg, this time F2 force is acting on it. Now let us take same mass m and consider the two forces acting on the mass simultaneously. Now what is physical independence is, if you consider this third case, F1 and F2, they behave independently. That means F1 will not bother about the effects of F2 and F2 will not bother about effects of F1. They continue to produce their own effects as if other forces are absent, and this is called physical independence. And if they don't bother, if they are physically independent, then what does it mean? Force is applied, then there will be a change in state of the body. So this is actually a consequence of what? Newton's first law of motion. If you want to know what is physical independence, this is the statement. Each force acting on an object produces its own effect as if other forces are absent. Now let's move on to next question. This was in NEET 2019. A particle moving with velocity v is acted by three forces and they are shown by the vector triangle PQR. Fine. The velocity of the particle will be, you have to comment on the velocity. So if you see the question, this is the vector triangle PQR and this triangle is represented by three forces. Let it be F1 here, F2 here, then this will be obviously F3. What is triangle law of vectors? If the two sides of the triangle are represented by two vectors taken in the same order, then the resultant of them is represented by third side of the triangle taken in opposite order. This is important. See, if you take A vector and B vector, this is how they are taken. They are taken in clockwise direction. But if you see the resultant, it is taken in opposite direction. So what will be the third side now? Third side is nothing but resultant. That means it is A vector plus B vector. And what is the condition? The third side must be taken in opposite order. Now the question says the three forces are representing vector triangle. So in order to apply the triangle law of vectors, the third side must be in opposite order, right? If you see the directions in the given diagram, clockwise F1, clockwise F2, and clockwise F3 is also clockwise. But in order to apply, we must reverse its direction. So what shall we do? Let us change it this as anti-clockwise. Then it becomes minus F3. Now apply the triangle law of vectors. What will you get? So resultant, that means F1 vector plus F2 vector. This is represented by the third side. What is on third side? It is minus F3 vector. Now bring this on the LHS side. So F1 plus F2 plus F3 is equals to 0, right? That means can I say F net is equals to 0? That means A net will also be 0. That means change in velocity is 0. So V initial will be equal to V final. So what is the velocity of the particle now? It remains constant. Clear with this? No. We'll do one more question. This was in 2008. Three forces are acting on a body as shown in the figure. So these are the three forces. 1 Newton force, 2 Newton force, and 4 Newton force. To have the resultant force only along y direction, the magnitude of minimum additional force needed is. See, what is the question? Read carefully. If you see these three forces, they are actually in 2D, right? They have x component, also y component. The question says the resultant force must be only along y direction. That means the resultant force along x direction must be 0. For that, what is the additional force needed? In order to make the net force along x direction 0, what is the force needed? Because along x direction, if F net is 0, then only you will have the resultant force along y, right? Now, so see this first force 1 Newton. What is its x component? It is adjacent side, right? So vector cos 60. Cos 60 is 1 by 2. Now if you take this 2 newtons, angle is not given but still you can find it. Vertically opposite angles are equal, 30. So what is the x component for 2 newtons? This is the perpendicular component, right? So vector sine theta. So sine 30 is 1 by 2. So I'll get 1. So along the positive x-axis, what is the total force? Half plus 1. This is 1.5 newtons, right? Now similarly find the x component for 4 newtons. This is the x component, and what is this? This is the perpendicular component. So vector sine theta. So this is vector sine theta. So how much will you get? 4 into 1 by 2? You will get 2 newtons. But this is along negative x-axis, right? So it will be minus 2. So minus 4 sine 30 minus 4 into 1 by 2, and this is minus 2 newtons. So along negative x-axis, what is the total force? Minus 2 newtons. Now see the question once again. We want the resultant force only along y direction. That means the resultant force along x must be 0. Let us check whether it is 0 or not. Negative side we have minus 2. Positive side we have just plus 1.5. If this side, if it is plus 2, then plus 2 minus 2 overall it will get 0. But the positive x-axis side, it is not 2, it is lagging zero point 0.5 newtons. So if you add or if you take extra 0.5 newtons, then total it will be 2 newtons. So that time if you take F net along x-axis, it is +2 -2, then it will become 0, and at that point of time you will have resultant only along y direction. So how much extra force we have to take? We have to take extra 0.5, because negative x-axis already 2 is present, positive x-axis side 1.5 is present. So take another 0.5, then +2 -2 gets cancelled. So how much is the additional force needed? It is 0.5 newtons. Clear with this? This was asked in 2008. Are you clear? Okay. Now we will see Newton's second law of motion. What was first law? It was very simple. If you apply force, then there will be a change in state of the body. Whereas in Newton's second law, we will see how much is that force. It talks about how much is the force. Whether it is 10 newtons or 100 newtons, how much is that? That we will discuss in Newton's second law. So the rate of change of momentum of a body is directly proportional to the force applied, and it will be in the direction of applied force itself. Read the statement. What is this momentum? We are having two categories of momentum. So here we are talking about linear momentum. So linear momentum is the product of mass and velocity. So its symbol is P. So P is equals to m into V, and P is a vector quantity. So if you take the change in momentum with respect to change in time, it is directly proportional to force applied on the body. So this is your Newton's second law. The rate of change of momentum is directly proportional to force acting on the body. What happens if you remove the proportionality? In maths, you might have studied, right? If y is proportional to x, if you remove proportionality, you will get some constant, right? So here also, if you remove proportionality, you will get a constant, and let that constant value be 1. Then what will you get? Then you will get F is equals to change in momentum by change in time. And this force is called average force. So what is F average? Change in momentum by change in time. What if I ask you F instantaneous? It is dp upon dt. It is dp upon dt. See, instantaneous means at a specific instant of time. That means very short interval of time. For short time intervals, we consider differentiations. So if instantaneous is equals to dp by dt. Now just substitute p is equals to mv here. What will you get? P is m into v, mass into velocity. Now differentiate, what will you get? M into dv by dt plus v into dm by dt. This formula is very important because this formula is always valid. Using this formula, you can solve any question. I mean, any question related to Newton's second law. So always valid. So important, remember this. For suppose, if I consider mass as constant, see 90% cases mass will be constant. It's a scalar quantity. If mass is constant, then what about change in mass with respect to time? It is 0, right? In such case, you can eliminate the second term, right? Let this be first formula. In the first formula, you can eliminate the second term if mass is constant. So at that point of time, what is F? M into dv by dt. And what is dv by dt? Change in velocity with respect to time. It is acceleration. So then you will get F is equals to ma. And this is the second important formula. And remember, this is valid only when mass of a body is constant. Clear? Everyone? So Newton's second law, it talks about the quantity of the force, the magnitude of the force. And first formula, very important, always valid. And second formula also important, valid only when mass is constant. Okay. In motion in 1D, we have studied about graphs, right? Now let us recollect them. Let us take time on x-axis and force on y-axis. And you got some graph, imagine. Okay. So what does the area of this graph represent? It represents the change in momentum. Because what is the area generally? So area is nothing but y coordinate into x coordinate. So y coordinate is force here and x coordinate is time. So F into T, or you can take delta T. So what is F into delta T? It is nothing but change in momentum. This is also important, third formula. So if a graph is given, you can find out the change in momentum by taking the area of the graph, making sure that force is on y-axis and time is on x-axis. Clear with this? So this is all about Newton's second law of motion. And before going for the problem solving, make sure you have learned these formulas 1, 2, 3. Okay. A body under the action of the force. So what is the force? This is a force. Acquires an acceleration. Acceleration is given. You have to find the mass of the body. So what is the formula? Use F is equals to m into a. If you see the options, options are not in vector format. So take the magnitude of F. What is magnitude of F? I component square plus j component square plus k component square. 6 square is 36, 8 square 64, 10 square is 100. So 36 plus 64 is 100, one more 100. So this is root 200. So what is the square root of this? 10 into root 2 newtons. So this is the magnitude of the force. Now just substitute it here. F is equals to ma. So F is 10 root 2. Mass we don't know. Acceleration is 1. So what is the mass now? Mass is also 10 root 2 kgs. So answer is option C. Very easy, right? You may get a doubt, ma'am. Do we get such direct formula based questions? Yes, and here is the proof. It was asked in 2009 NEET exam. Sand is being dropped on a conveyor belt. Okay. At the rate of, okay, question is missing, at the rate of capital M kg per second. The force necessary to keep the belt moving with a constant velocity of v meter per second. See, velocity is given, which is v meter per second, and dm by dt is given, which is m kg per second. See, this time mass is not constant. Why? Because in every 1 second time, how much sand is dropped on the conveyor belt? M kg is dropped. That means if you take 2 seconds time, m plus m, 2m kg mass. If 3 second times, m plus m, 3m kg mass. That means with the time, the mass of the sand being dropped is also changing. So mass is not constant here. What is constant here? Velocity is constant. So can I say now change in velocity with respect to time is 0? Because velocity is constant, so change will be 0. So you have to find the force. So which formula will you use now? Is F is equals to ma, suitable here? No. So use the first formula, m into dv by dt plus v into dm upon dt. Now what is 0 here? Constant velocity. So this term is 0. So v is v only, dm by dt is m. So what is the force now? V into m newtons. So it is in which option? It is in option C. Very simple. Just you have to understand the question. Now see the sixth one. An object of mass 3 kg is at rest. That means its initial velocity is 0 meter per second. Now a force, F value is given. Now this much of force is applied on the object. Then the velocity of the object, that means final velocity is question mark. at a time of 3 seconds. See, this is a combination of first and second law. Initially, the body was in rest. They are asking velocity after some time. That means the body was in motion. After applying the force, so force is applied, body is changing the state. So Newton's first law. Okay, and related to some numericals, that means also related to second law. And if you see the options, the final velocity is in vector format. Fine. So first find the acceleration using this formula. F is equals to m into a. So what will be a? It is nothing but F by m. Do it. So 6t square I cap plus 4t j cap whole divided by what is the mass? 3 kg. So how much will you get? 2t square I cap plus 4 by 3t j cap. This is the acceleration. Now you have to find velocity, right? How do we find velocity? From the expression of acceleration, recollect the motion in 1D concepts. Velocity is equals to integral a dt, because this time acceleration is time dependent and limits will be t1 to t2. So integrate, what will you get? T square integration is t cube by 3, 4 by 3 as it is. T integration is t square by 2. And what are the limits here? 0 to 3 seconds. So substitute upper limit, what will you get? 2 by 3 into 3 cube, 3 3 is 9, 9 3 is 27, plus 4 by 3 into 4 by 3 into 1 by 2 was also there. T square, that means 3 square, 9. What about the lower limit? If you substitute the whole first term and second term, it is 0 only. So just simplify this, how much will you get? 3 ones 3, 3 nines 27, 3 ones 3, 3 threes 9, 2 ones 2 twos 4. Sorry, I just forgot to mention the I cap and J cap. So this is I cap, this is J cap, and this is I cap, this is J cap. So you'll get 9 twos 18 I cap plus 2 3 6 J cap. So this is the velocity. That means along x 80 meter per second and along y it is 6 meter per second. Yeah, it is in option B. Clear? See, according to the options given, simplify your answer. Now, a force of 6 newtons acts on a body at rest. That means initial velocity is 0 meter per second. And what is a mass? 1 kg. Force is 6 newtons. During this time, the body attains what is the final velocity of the body? V, that is 30 meter per second. The time for which the force acts on the body. So this time you have to find T value. See, F value is given 6 newtons. M value is given 1 kg. So from this data, find out acceleration. What is acceleration? F upon m. So F is 6, mass is 1. So what is acceleration? 6 meter per second square. First step, is it clear? Now, what is the other given data? Initial velocity is 0 meter per second. Final velocity is 30 meter per second. They are asking us the time. And you also got the acceleration now. So use this formula, equations of motion. V is equals to U plus A into T. So V is 30, U is 0, acceleration 6, time we don't know. So simplify this, how much will you get? 30 is equals to 6 into T and T is equals to 30 upon 6. How much will you get? You will get 5 seconds. So what is the answer? Option B. Is it clear, everyone? Let's see the next question. A 10 newtons force is applied on a body, produce in it an acceleration of 1 meter per second square. The mass of the body is. So use F is equals to m into A. Force is 10 newtons. Mass we don't know. Acceleration is 1. So what is the mass now? Mass is nothing but 10 kg. So option number C. See this question. A force vector is applied on a mass is represented as, so this is the force. Vector form is given. And because of this force, the mass is accelerating with 1 meter per second square. What will be the mass of the body? So use the same formula, F is equals to m into A. But if you see options, there is only magnitude. So find out the magnitude of F here. Under root I component square, J component square, K component square. I think this is the same expression we got in previous year question, no? So 6 square 36, 8 square 64. So what is the summation? You will get 100 and 10 square is 100. So you'll get square root of 200, which is 10 root 2 newtons. So substitute here. Force is 10 root 2. We have to calculate the mass and acceleration is 1. So what is the mass now? Mass is also 10 root 2 kgs. That means option C. Now, a satellite in force free space. What do you mean by this force free space? That means the satellite is not under the influence of other forces. Sweeps, see, generally satellite will be in the space. There are some bigger planets in the universe. So there is a chance of gravitational pull, right? So force free space means there is no gravity, I mean gravitational effect from the other bodies on the satellite. So it sweeps the stationary interplanetary dust, fine. And what is the sweeping rate? dm by dt is equals to alpha into v, where m is the mass, v is the speed, and alpha is a constant. So we need to find the acceleration of the satellite. So use F is equals to ma. So what will be acceleration? It is F upon m. So mass of the satellite is capital M, but what about the force on the satellite? We don't know, right? So take this as 1. Find out the force. How can we find out the force? F is equals to m into dv by dt and v into dm by dt. Now the satellite is revolving with how much speed? It is revolving with v speed. And the orbital velocity of satellite is constant, right? So you can eliminate this term. Change in velocity is 0. So V is V only and dm by dt, it was given in the question alpha into V. So this is alpha V square newtons. So how much is the force? Alpha V square. So just substitute that data here. So force is alpha V square and mass is capital M. So what is the acceleration of alpha V square per M? Why there is negative sign in every option? It means the acceleration produced in the satellite is in opposite direction. That means it is actually retardation. That is why minus sign is included. So what is acceleration? Alpha v square by m. Now, conceptual question. If you can solve these kind of questions, it means that you are good enough with the concepts. A balloon with mass m is descending down with an acceleration a. Fine. So this is the balloon. Its mass is m kg. Now it is moving downward. This is the direction of motion of the balloon. And what is the acceleration? A meter per second square. And this A is less than g. That means less than 9.8. How much mass should be removed from it so that it starts moving up with an acceleration A? It is missing in the question. This time also acceleration A. So what is the question? So this time from the balloon, some amount of mass is removed. So let us assume m naught mass is removed. We don't know whether it is 1 kg or 2 kg removed, right? So let us assume m naught removed. So what will be the mass remaining in the balloon now? It will be m minus m naught kg, right? And after removal of mass, this time the balloon is moving upward. So this is the direction of motion and this time acceleration is same, a meter per second square. What is the question? You have to calculate this removed mass. So how shall we do this? Using Newton's second law. And what do we do here? We apply F net is equals to ma. Why not directly F is equals to ma? If there is one force, we will use F is equals to ma. But here it is not one force. Let us see the case. See the first case. What will be the force that will be acting downward? Weight of the balloon, which is m into g. Balloon is in the air. So what will be in the upward direction? You will have upthrust, right? What is this F actually? It is the upthrust. And up thrust is a force. Up in the sense this thrust, this force is in upward direction. So on the balloon, two forces are acting now. One is weight of the balloon, the other is upthrust. So two forces are there. That's why you have to take F net is equals to ma. So apply that F net is equals to ma. Now what will you do? F net, two forces are in opposite direction. So you have to take the difference. And what minus what? How will you decide that? See the motion. Motion is downward. So mg minus upthrust is equals to ma. Motion is downward in the sense downward side force is more. So always how do you do the difference? Bigger value minus smaller value. So what is F now from this? Can I write mg minus ma? So take it as 1 and keep it on hold. Let's move on to the next case, second case. Some mass is removed, fine. Now downward, what will be the force? Weight. Weight is nothing but mg, but this time m is m minus m naught. M into g, but m is m minus m naught. And as usual in upward direction, what we will be having? We will be having upthrust. Okay. So here also same, apply F net is equals to m into a. So how will you take the difference now? This time the body, the balloon is moving upward. So that means in upward direction force is more. So upward force minus downward force is equals to ma. M is this time m minus m naught into a. So let's simplify this. I'll just continue here. What is F here? Substitute it better. From equation, substitute the value of F. So mg minus ma. This is F. Minus, simplify this whole, what will you get? Minus m into g minus mg. Minus minus plus m naught into g is equals to m into a minus m naught into a. We have to find m naught. So take all the m naught terms on one side. Before that, anything gets cancelled here. Plus mg minus mg cancelled. Okay. Now get the minus m naught a this side. So m naught g is already present. From that side m naught a. On RHS side already MA is present and send this minus MA that side. So it will get plus MA. So take out M naught common, you will get A plus G. This is equals to 2MA. So what is M naught now? It is 2MA upon A plus G. So this is the mass that has to be removed. What is the condition in the question? The balloon must have the same acceleration A, but the direction of motion is changing and some amount of mass is removed. So how much is the mass removed? 2ma by a plus g, option A. So we just have to apply Newton's second law, F net is equals to ma in both the cases, and just we have to be careful in simplification. Clear? Don't worry, because if you see the problems that we have, that we are solving today, most of the questions were very easy. Only some questions like this. This is also easy, but a bit concept is required. That's it. Now let us see another question. A monkey of mass 20 kg is holding a vertical rope. So let this be the vertical rope. So monkey is holding this rope. And what is the mass of the monkey? It is 20 kg. The rope will not break when a mass of 25 kg is suspended from it, but it will break if the mass exceeds 25 kg. So what does it mean? See, generally, if you take a rope or a string, what is the force in it called? It is called tension force, right? Tension T. And how do you find this tension? It was given in the question. See, always tension will be away from the mass. Imagine this is the horizontal support, this is the rope, and some mass is hanged to it. So in this case, what is the direction of the tension? It will be away from the mass. Tension is always away from the mass. This is the direction of tension. Now, if this mass is 25 kg, then the rope will not break. In the sense what, how do you calculate tension here? See, downward there will be weight. So weight is how much? M into G. So 25 into G. And here the mass is not moving. So in this case, if I apply F net is equals to MA, F net is 0. So that means tension force and weight, they are balancing each other. So I can say tension is also 25 into G. If you substitute G value, it will be 250. Clear with this? So the rope is not breaking for a maximum mass of 25 kg. So what is the tension in the rope now? 25 into G. And this tension is away from the mass, right? So this is the rope. So away from it, this is 25 into G. Now, the monkey was moving upward. It is climbing up. So this is the direction of motion of the monkey. What we need to find in the question? What is the maximum acceleration with which the monkey can climb up along the rope? So this means you have to find the acceleration of the monkey. So do it very simple. The weight of the monkey will be downward, which is M into G. Mass of the monkey is 20, so 20 into G. So we have two forces here. Number one, weight, and number two, tension. And the monkey is in motion now. So it is in motion, so F net is not 0. So what is F net here? F net is equals to M into A. Apply Newton's second law. F net is equals to MA. Monkey is moving upward. That means upward side force is more. So T, tension, minus weight is equals to M into A. Tension is 25 G. Weight is 20 into G. And mass of the monkey 20. Acceleration we don't know. Simplify this. How much will you get? 5 into G is equals to 20 into A. Let us see the options once. Okay, G is not mentioned in the options. That means you have to substitute G value. So what is A now? 5G. That means 5 into 10 upon 20. You can take 9.8 also. But as I discussed in earlier chapters, take 10 for simplicity. So what gets cancelled here? 0, 0 cancel, 5 by 2. So what is half of 5? It is 2.5 meter per second square. So what is the acceleration of the monkey? Acceleration of the monkey is 2.5 meter per second square. Clear with this? Practice once, okay? Let us see another question. Same related to monkey only. Monkey is descending from the branch of a tree with constant acceleration. Fine. If the breaking strength of the branch, see this time you can consider the branch of a tree similar to rope only. So in upward direction we will have a tension. That means breaking strength in the sense tension here. How much is that? 75% of the weight of the monkey. The minimum acceleration with which the monkey can slide down without breaking the branch. So this time the monkey is climbing down. So what is the direction of motion of the monkey? Downward. Now, so if I consider this as the monkey of mass m, its weight is downward mg. And in the upward direction, we have tension force. How much is that? 75%. That means 75 by 100. How much will it be? 3 by 4 the weight. That means 3 by 4 into mg. And the monkey motion is in downward direction. So apply F net is equals to MA. What will you get? So motion is in downward direction. So mg minus tension. Tension is how much? 3 by 4 mg is equals to m into a. So I can write it as 1 mg, right? So 1 minus 3 by 4, it is 1 by 4. So 1 by 4 mg is equals to m into a. If you see the options, g is not substituted. So keep it the same. M gets cancelled. And what is acceleration now? It is g upon 4 meter per second square. That means acceleration of the monkey this time is g by 4. Option C. Any difficulty? Just go through once what we have done in monkey problems. Clear? All right. So today we have covered Newton's first law and Newton's second law. And more importantly, we have solved 15 years of NEET previous year questions. And you might have noticed that questions are mostly direct applications of F is equals to MA. And here and there, some questions are concept based. And a clear understanding of basics can help you score easily. So revise these concepts and practice similar questions, and this topic can become one of your strongest areas in physics. So make sure you go through today's questions once again, try solving them on your own, and if you have your college questions or some other books, from in which you are preparing, so practice them as well and note down the important points. In the next class, we will continue the remaining topics, the further topics in this laws of motion. Okay. So thank you everyone. Keep practicing, stay consistent, and have a nice day. Bye bye.